day, everyone. Bob Bosworth here, and I'm going to be your host for the next 5 to 10 minutes. I'd like to discuss a little bit more about, or explain a little bit more about push versus pull when it comes to the outcomes of gas metal, metal core, and flux core type electrodes in your typical wire feed processes. There's so much folklore and conjecture out there. I thought it'd be a good idea that we went a little bit more back to basics. So shall we? So this is your typical push, and so let's talk about some of these parts of the configuration. Let's remember that push is when you're pointing forward and you're traveling in this direction. So when you're pushing the arc, there's an area right in front of the weld. Remember, it's not on top of the weld, but in front of the weld that should be making good contact. Plasma should be making a good contact with the base metal. Now, this is especially true when it comes to galvanized materials, because this is the area that degalvanizes that area to make an effective weld without having crazy amount of porosity. So let's remember what pushing is first. So there's a penetration profile you get in push versus pull. And this is the penetration profile you see when it comes to welding with a push. You'll get a wider weld profile with a narrower or shallower depth of penetration. So it doesn't quite go in as deep. Now, opposed to a drag where you have the arrows pointing the direction, we're moving it along, and we're trying to keep the wire right where we're supposed to, right on the edge of that puddle for good plasma conductivity right there, which means heat. But look at the difference right here. So if we were to look at this again and I were to flip it back and forth, you can see there's clear differences between pull, push, pull, push, pull. Now the reason we're seeing this weld that's high like that is because when you drag, you make good, and it always ensures good contact, as long as your speed is where it's supposed to be, of the plasma with the base metal. Because of that, it digs in quite deeply and picks up a lot of cool metal that's underneath the surface. So the more metal it picks up, the more it gets, the cooler metal gets into the puddle, and it keeps it from wetting out. It keeps it from getting this condition where we refer to it as wetting out when the weld becomes a little wider. So again, that's push, pull, push, pull. So if you have any questions about that, I hope that clears up a little bit of the conjecture about it. But there's one thing I just want to say in closing. This is one of those places where there's no substitute for technique. I could give you the best parameters in the world. My colleagues and I could give you the procedures for how you're supposed to do things. And it doesn't matter what we could provide you. When you're on your own with a gun, and you pull that trigger, you can make or break those procedures. So just keep it in mind when you're given procedures and you have to execute to them. Thank you very much.